Hey everybody, sorry I'm a few minutes late in posting this, but so these are the 4 examples we're going to do to wrap up our lesson on logarithmic functions. So last set of examples we're going to take a look at are going to deal with solving mostly log equations, but we have one exponential equation in here that I want to talk about as well. Okay, so for the time being, when we solve log equations, and we're going to talk about like more advanced techniques of doing this later on in this unit, but for right now, when we solve a log equation, we typically want to rewrite the log equation in an exponential form. Okay, so when we look at the first one, the log base x of 4 is equal to 2. If I write that log in exponential form, the base of the exponent will be x, the power will be 2, and that's going to be equal to the argument of the log, which is 4. Okay, so we can solve this equation here, taking the square root of both sides, and the square root of x squared is going to become the absolute value of x. The square root of 4 is 2, which is going to make x equal to plus or minus 2. And if you list both of those solutions, that's actually incorrect. So let's go back and take a look at why at the very start of this lesson. Okay, so we define the logarithm to the base a, where a is greater than 0 and a cannot be equal to 1. Okay, so we have a is greater than 0, a cannot be equal to 1, and that applies to our base. Okay, so the base has to be positive and it can't be equal to 1. So when we go back to our solution here, the only solution we can keep is the positive one, and that occurs at x is equal to 2. Okay, for the second one, the natural log of e raised to the negative 2x power is equal to 8. Again, to solve this equation, we want to write this log equation in exponential form. So natural log is log base e. The exponent is going to be 8, and that's going to be equal to the argument of the log, which is e to the negative 2x power. Okay, now this transforms into an equation that we solved in the previous section. So we have both sides of this equation written as an exponent that shares the same base. So for those to be equal, that means that their powers have to be equal. So negative 2x has to be equal to 8. And then when we divide both sides by negative 2, we get x equal to negative 4. Now, the last thing we want to check is when we plug this solution into this formula here, is the argument going to be positive? So when I plug negative 4 in the place of x, the argument becomes e raised to the 8th power, and 2.7 raised to the 8th power is a positive number. So that solution there is going to work for us. Okay, let's take a look at number 3. So for 3, we have e raised to the 2x plus 5 power is equal to 8. So we have an exponential equation here. The problem that we have with this exponential equation is we can't get both sides of this equation written as an exponent that shares the same base. Like, I don't know how to write, well, I do. You guys don't know how to write yet. You will in the next lesson. Learn how to write 8 as an exponent with base e. And we also can't write e as an exponent with like base 8 or like base 2. Okay, we can't do that. Okay, so the only other like technique that we have where maybe we can work with in this instance is to rewrite this log equation in an exponential form. So we have, if I write this log in exponential form, the exponent base e is going to have a log with the same base. So that is log base e, which is natural log, of what the exponent is equal to, which in this case is 8, and that's going to be equal to the power 2x plus 5. Okay, so when we solve this equation here for x, I can subtract 5 on both sides, so we get 2x equal to the natural log of 8 minus 5, and then I can solve for x dividing both sides by 2. So we get the natural log of 8 minus 5 all over 2. All right, so that right there is our solution for x. Okay, last one, log base 5 of x squared plus 21 is equal to 2. So again, to solve this log equation, we're going to write the log in exponential form. So the base of our exponent is 5, the power is 2, and that's equal to x squared plus 21. And then we can go ahead and solve the equation for x. That's going to make x squared equal to 5 squared is 25 minus 21. So we get x squared is equal to 4, which makes the absolute value of x equal to 2, which makes x equal to plus or minus 2. So the last thing we have to check is when we plug plus or minus 2 into our argument here, is the argument going to be positive? Well, we know when we plug in 2 squared is 4, plus 21, that's 25, that's positive. When I plug in negative 2 squared is also 4, plus 21 is equal to 25. So that's positive as well. So both of these solutions here are good for us. All right, and that's going to be it, guys. So that should give you what you need to work through all of your homework. Again, make sure you guys get both assignments turned in by Sunday, and I hope you all have a great 3-day weekend. We'll see you all on Wednesday. Take care. Bye.